Hello everyone and welcome to my YouTube channel, Wrong Math. Today, we will be exploring one of the most important concepts of physics, namely the centripetal acceleration. So what is centripetal acceleration? We have all played with a ball tied to a string and swirl it around in circles, or at the least seen this happen. Intuitively, we can understand that as we revolve the ball, at each point the ball is being pulled by the string with some force that keeps it from flying away. And we call this inward force maintaining the circular motion to be called centripetal force, and the acceleration caused by the force is called centripetal acceleration. Now let us understand in detail the derivation of centripetal acceleration by considering a ball moving in uniform circular motion with a constant velocity, v. Its velocity vector is perpendicular to the radius at each point in its circumference, and the centripetal force acts in the radial direction at each point to continuously change the direction of velocity. To know why it maintains a constant velocity, you can refer to one of our previous lectures on uniform circular motion. Now let us take a tiny portion of the circular motion, where the ball travels from the point A to point B. Consider the velocity at A to be VA and velocity at B to VB, each acting tangential to the circumference, and assume it moves from A to B and the angle between two radial vectors R1 and R2 be some small angle delta theta. Now move the vector A forwards and vector B backwards so they intersect at the point C, such that the angle ACB makes 180 minus delta theta. This is based on the laws of quadrilateral angles. We now get the exterior angle of C to be delta theta. When a body maintains constant velocity in circular motion, it implies it has constant angular velocity, let's say omega. Since acceleration deals with change in velocity per unit time, let us assume the time interval for the ball to travel from A to B to be 1 second. This further tells us that angle swept by the ball in 1 second is nothing but delta theta, equal to omega. Zooming into the exterior angle of C, we can see the velocity vector A upon rotating through an angle, omega becomes vector B. We can divide this change into multiple small portions, where the velocity goes through small delta V changes along the arc to find the resultant vector from vector VA to vector VB. For the sake of simplicity, let us divide it into only 4 portions and join all the tiny delta V vectors to get vectors P1, P2, P3, and P4. Each of the tiny vectors P1, P2, P3, P4 essentially represent the small delta change in velocity. We know that acceleration is defined as change in velocity per unit time. In this case, all the tiny several changes acting along the arc length when added up essentially represents the net change in velocity in a unit time of 1 second. So we can intuitively correlate the arc length made by the two vectors to be the change in velocity per unit time, which is nothing but acceleration. Therefore, giving us centripetal acceleration to be v multiplied by omega, and by further simplifying the equation further by substituting omega as v by r, we would get the final equation for centripetal acceleration. This is what the objective of this video was to prove. If you liked the video, hit the like button. And to learn more such interesting math and physics concepts, subscribe to my YouTube channel and stay tuned with us.